Jai Hind to all. Myself Yogendra Prajapati, Assistant Professor Ajay Kumarkar, Engineering College, Ghaziabad. Dear friends, today I am going to teach very important topic of the compiler designing, that is known as the bottom-up parsing in LR0 parsing. In LR0 parsing is basically this is the structure of the LR0 parsing. In basic structure of LR0 parsing, the main important is the input buffer string, in which we store the input of the context-free grammar or any given language. Now, the second important part of the basic architecture of LR0 parsing, that is known as the stack. With the help of stack and shift reduce algorithm is also involved to find the canonical element of the context-free grammar, and we draw the action and go to table of the any given context-free grammar. Basically, in action part, all the terminal are involved like ABCD, and dollar is also contained in the part of the action, and in go to part all the non-terminal are contained, include the start symbol of the context-free grammar. And now this is the state of the DFA, which is also we design for the canonical element of LR0 parsing item. That is the parse table, and with the help of stack, action go to table, and shift reduce algorithm, we design the final outcome of the LR0 parsing algorithm. Now, this is the some basic procedure by which we design the LR0 parsing table. LR0 parsing table. Now, obtain the augmented grammar for a given grammar. The first step, we design the augmented grammar of any given context-free grammar. Now, the second step, create the canonical collection of LR item to compile the given context-free grammar. And the third, design the DFA and parse table with the help of the DFA. Then we design the LR item of the given context-free grammar. LR parsing table allow the, that is very also important point for the LR0 parsing table. In LR0 parsing table allows also the ambiguous grammar. In the parsing, their parsing grammar is allowed, should be taken as the should be not be modified, and that given grammar is not modified. The grammar which is obtained by adding one more production, that is known as the short single of the grammar, is also known as the augmented grammar. Now, the first statement, we design the augmented grammar. So, how we can design the augmented grammar? We first add in start symbol, that is S tends to S dash, that is known as the augmented grammar. S dash tends to S, and this type of the grammar is known as the augmented grammar. Yes. Now, this one is known as the augmented grammar. Now, we better understanding, we take the very simple example for the LR0 parsing algorithm. Now, the main grammar is this is your context-free grammar, and this is known as the augmented grammar. Now, we create the augmented grammar. S dash tends to S, and S tends to A, B, and A tends to A, and B tends to B. Now, this is the initial state of the DFA. With the help of augmented grammar, we design the conical element of the item and also design the DFA of this machine. Now here is a star, dot, dot and dot. This is the method by which we design the conical element of the LR parsing table. Now what is the first step? Dot move here and output is yes, and yes dash tends to yes. This is known as the final state. If dot in the last of the any production, then that state is known as the final state. That is the I0 state, that is the I1 state, and I1 state is a final state. We apply this rule for all production rules. Now we open the yes, and yes tends to AB, and again we rule open A tends to A, and only this production. Okay. When we open this production, we find this production role. This is known as the no, here we A, and here this, and here this. And when we open production A and A tends to A dot, that is the final state, and B tends to B dot, this is your final state. Now with the help of this is the method by which we explain the conical element of the LR0 parsing algorithm. Okay. Now we explain here again B, and yes tends to A B dot. This is the final state of the finite automata. This production has been explored. Now B tends to here. Now this is here, move from here, and this is B. And this is also final state. This is also final state. Now this is the finite automata of the given LR0 parsing algorithm. With the help of this finite automata, we draw the action and go to table. Okay. Now here we draw the action and go to table. Now in action part, and here is a go to part. In action, all terminal are contained like A, B and dollar. And in go to part, that is yes, A and B. And how many states are involved in this finite automata? We draw the action and go to table. That is I0, I1, I2, I0, I1, I2, I3, I4 and I5. I0, I1, I2, I3, I4 and I5. With the help of action, this finite automata, we draw the action and go to table. Now in I0A, from that is I0 and that is A, we move from the I3, that is shift 3, and from this state B, and we move from the state 4, that is yes4, and no state from the dollar, and from yes that is 1 and A that is state 2 and no input from the B state. Now I0 state has been complete and we find this transition table. Now on this I1, from I1 dollar that string is accept. From I2 B, from I2 B we move to the 5 and from I2 B, small b, we move from the state S4. It means BS4. Now this state is also complete. I3, that is your final state. All final state use the reduction rule and all non-final state use for the shift operation. Now this is production rule 1, this is production rule 2, this is production rule 3. It means on the state number I3, which production rule are applied? Production rule 2. It means here R2 are filled. I think everything is clear. Now we apply the similar. I4 is also final state and I4, this production rule, that is known as the I3. It means here we fill R3 and R3. This is production rule number 1. This is also final state. On the final state we always apply the reduction rule. For all non-final state we apply the shift rule. Now in R5, that is R1. Now this is known as the LR parsing table. Now this is the final. With the help of this table, stack conical element, we finally conclude the answer of this problem. Now for the better understanding, we move from the another example. This is another example. This is also a very important example. This is another grammar. What is the first rule? When we are going to solve this kind of the problem, we first find the augmented grammar. So what is the augmented grammar of this problem? E dash tends to E and now E tends to T plus E and E to T and T tends to ID. This is known as the state I0 and here is, if here is you put this, then explain E, then explain T, here T tends to ID and E tends to this. Now this first step has been complete. Now we design the deterministic finite automata using this concept. For this production rule, we find the input E and E tends to E dot. That is your final state of the finite automata. And this production has been over. Now here we find the T and T tends to E tends to T dot plus and E and plus, then no further explanation are allowed. Now here again we T to E tends to here T dot. Because this out the same output and he turns this production has been explained, this production further explanation. Again is here ID and T tends to ID dot. This is the final state. This state is complete. Now remaining this state has been further expanded. Now here plus and E tends to T plus this and E. Dot before the E non-terminal, it means it's shown we explore this production rule. It means E tends to T plus E and E tends to T dot. Then we need to again explain T tends to ID. No further explain. This is also this has been also explained. No further. Now we explain this one. Now here E and T, E tends to T plus E dot. This state has been completed and this is the final state. Yes. If we move this, then no further explanation are allowed. It means T and E tends to T plus this and E, and again here this one. Okay, and when we explore this one, we move from here, that is the ID. Now this is the final state or this is the non-final state. If we explain plus here, then we find the same state, that is the plus. And when it is auto explained, I think this has been completed. Plus E. Yes, this has been. This is the finite automata of this given grammar. With the help of this finite automata, we draw the action and go to table of the this given context free grammar. Now, how many state? This is I0. That is I1, I2, I3, I4, I5, I6 plus E. Explain this one. No problem. Everything is fine. Now we draw the action and go to table. This is the final result we are going to compute of this given context free grammar using LR0 parsing algorithm. Now we need the some space. Now here we don't need this one, so we remove this one and we assume that this is the I0, no problem, and we draw here action and go to table. How many terminal are here in this production rule? Very simple. Terminal is your only plus and ID, and one more thing is dollar, and that is E and T. That is the this portion is known as the action, and this portion is known as the go to of LR0 parsing table. Now how many state? That is I0, I1, I2, I3, I4, I5 and I6. That is I0, that is I1, I2, I3, I4, I5 and I6. Now from I0 plus no operation. From I0 to ID, that is I3. It means here is a shift 3. And from E, that is 1. From T, that is 2. State number 2, I2. And plus no operation. Now this parsing table has been complete for this state I0. I1 dollar, that is accept. Okay. Now out. This is the I2 state. For IT, I2 state for the plus, that is the, we move from the S4 shift 4 operation. And for ID, no operation. And from I2, no, this is one has been completed. From we move from the I3. I3 is your final state. I5 is your final state. And I1 is your final state. I have already explained that on the final state, we apply the reduction rule. For the non-final state, we apply for the shift rule. Now, I3 is your final state. On production rule 1, 2, 3. That is R1, that is R2, this is R3. So, we apply the reduction rule from the state number 3, that is R3, R3, R3. Okay, we move from the state number 4. On state number 4, that is this one. On the E state, we move from the I5. So, from the E, move from 5 state. And from the T, we move from 6 state. And from ID, we move from the S3. From ID, we move from S3. Now, this table has been complete. We move from the state number 5. State number 5 is the final state. Now, this is the production rule 1. And it means here is a R1, R1, R1. And any other rule? No. We move from the yes. We move from the I6. Yes. I6 that is R2 and shift 3. From the plus operation, for the plus operation that is known as the S4. And also S4. This is the final state. Yes. It means on I2, this one is your final state. And that is I2, or this is known as the production rule number 2. Now, production rule number 2 is applied on the I2. Here is it means that is R2, R2, and R2. It means in action table, if shift and reduce are applied on the same box, then that grammar is not LR0 grammar, because that is the problem on the action and go to. In single, either shift problem, shift, both two shift are applied, or both RR problem. It means here apply shift reduce problem. On the same state, this is kind of the problem. This is not a contest free grammar. For the better understanding, we move from the another example. And here is another problem has been that is the I6. That is here is also R1, R1, R1. Then in this table, in this section and in this section, shift reduce problem are occur. And in my another lecture, I have explained what is the shift and reduce problem. And please see this lecture number 4. From the any LR0 grammar have two kind of the problem, shift reduce problem, and another one is the reduce RR problem and SR problem. Okay, so this grammar is not a context free grammar because on the plus operation shift reduce problem are occur. Okay, for the better understanding, we need another example for the context free grammar. We simply first, what is the first state? We draw the augmented grammar. Yes dash tends to dot yes, and yes tends to A and B, and yes tends to B and yes tends to BAC, and yes tends to ACB, and A tends to ABA, and B tends to B. A ka production we have already explained here, B no problem, and here and here. Now this is the state known as the I0 state. That is very simple. And here that is known as the yes, and yes tends to yes dot. This is known as the final state. And here A, and no problem, A, and then yes tends to A, B. Any other A? No, any other A. Now this is, we move from here. Now here and again that is small b, and yes tends to B dot A dot B, and again here yes tends to, here is also B, so B dot A and C, any B, and here again B tends to B dot. This is the, we explore which production, this production, and this production, because input is B. Then we are combined into the single state. Now remaining this state has been yes tends to A dot C, A, yes, A dot C, this is C, and now B, and yes tends, sorry, A tends to A dot B and A, and we explore the B production, that is B tends to B, and here is A, input is A. Now we check this given grammar is a LR0 grammar or not. If shift reduce problem occur, or reduce problem or RR problem occur, then this given grammar is not a context free grammar. Sorry, LR0 grammar. Now we explore this one. Now yes tends to here is A, and yes tends to A dot B. Further B not explore much, and here is A. Now and this one is a left it, no problem. Here is a A. This was the final state, no further explanation are allowed. Now here yes tends to BA dot B, and yes tends to BA dot C, and here is no further statement is allowed. Here this one, now here explanation, here is a yes, we explain C. Now C, so yes tends to AC dot B, B is a terminal, not for need to further explanation. And here is a now here what is this one, A, so this is A tends to A B dot A, so we need to further explain for the A production rule. And now what is the A production rule? This is the, yes, we need to further explain. This is another rule. What is the A production rule? A production rule, that is the A tends to dot A B A, and here is a B, and B tends to B dot. This is the final state. Again this is your final state, no problem. That is the B, and yes tends to A and B dot. This is your final state. Now this is again your final state. Two final state we find out, and that is known as the here B, and I think this one is also B. Now this one and yes, this one, both are the final state. C, we further explain in the S tends to B A B and S tends to A C B dot. This is your final state. We further explain here, that is again this is same output B. Now C here and here S tends to B A C dot. This is your final state. Yes, this is final state, and this is again final state A. A tends to A B A dot. This is your final state, and here B. Further we need to B explanation and B this one. Yes, we move lot of examples. I think better understanding for the next classes. We continue this problem because time is I think is sufficient. Okay, thank you. We meet for the next lecture to continue this problem. Okay, thank you.